The engine roared to life with a sound Klaus Ritter had never heard before. It wasn't the familiar clatter of a Maybach V12 that powered his Panther, nor the deeper growl of the Tiger's engine he'd trained beside. This was something altogether different, a smooth mechanical purr that seemed almost incongruous with the 46-tonnen steel beasts surrounding him. Through the vision blocks of the M26 Pershing's driver compartment, the ruined streets of Eldorf stretched ahead, and Ritter's hands trembled slightly as they gripped unfamiliar controls. It was March 21, 1945, and the veteran Panzer commander was about to drive an American heavy tank through what remained of a German town. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Pershing had been captured intact 3 days earlier, a stroke of fortune so rare it bordered on the miraculous. American tankers, pressured by a sudden counterattack near the Earth River, had abandoned their vehicle after track damage, immobilized it in a forward position. By the time Wehrmacht recovery crews reached it under cover of darkness, they found something their intelligence officers had been desperately seeking, a complete functional example of America's answer to German heavy armor. Within hours, the tank was being towed eastward away from the collapsing front lines toward a provisional testing ground, established in the relative safety of a commandeered farm outside Cologne. Ritter had been summoned specifically for this duty. At 32 years old, he carried the experience of 4 years of armored warfare from the dusty expanses of North Africa to the frozen hell of the Eastern Front, and now to the shrinking perimeter of the Reich itself. He had commanded Panzer III's against Matildas, Panzer IV's against Shermans, and for the past year a Panther against everything the Western Allies could field. He understood the language of armor, the grammar of gunnery, the vocabulary of velocity and penetration, but as he settled into the Pershing's driving seat, he felt like a linguist confronted with an entirely foreign script. The Americans called it the M26 heavy tank, though by 1945 the U.S. Army had reclassified it as a medium. This semantic distinction mattered little to the German tank crews who first encountered it in combat. What mattered was the profile lower than a Tiger, more compact than a Panther, yet clearly heavier than the ubiquitous Sherman. What mattered was the gun, a 90mm cannon that could engage German heavy armor at ranges previously thought safe. And what mattered most, as Ritter would soon discover, was the combination of firepower, protection, and mobility that represented a fundamental shift in armored warfare philosophy. The testing ground was less a facility than an improvised arrangement. A cleared field served as the driving course. A hastily erected tent housed the technical evaluation team, engineers and officers from the Waffenamt, the Weapons Procurement Office, alongside representatives from the major German tank manufacturers. They had arrived with measuring instruments, bore gauges, metallurgical testing equipment, and an urgency born from desperation. Germany was losing the war. But perhaps in the captured enemy technology, there might be lessons to salvage, insights to apply, marginal advantages to extract from the jaws of inevitable defeat. Oberstwehrer Schulzer, the senior evaluation officer, had made the mission parameters clear during the morning briefing. They would conduct a comprehensive assessment, driving characteristics, gunnery trials, armor examination, and most critically, a frank comparison with Germany's own heavy tanks. Schulzer was a career officer who had helped develop the Panther program, and his technical acumen was matched only by his pragmatism. He understood that this evaluation wasn't about propaganda or maintaining illusions of superiority. It was about truth, cold and metallic, measured in millimeters of armor plate and meters, yes, of muzzle velocity. Ritter engaged the transmission. The Pershing lurched forward with surprising smoothness. The torque-o-matic transmission, though he didn't know its designation, yet operated differently from the pre-selector gearboxes in German tanks. There was a fluidity to the power delivery, an almost automatic quality to the gear changes that seemed wasteful of engineering complexity, yet undeniably effective. He guided the tank through a series of turns, feeling how it responded. The tracks gripped the muddy soil with authority. The suspension absorbed irregularities in the terrain, with a compliance that reminded him more of automotive engineering than the harsh purpose-built systems in German designs. The steering is responsive, he reported through the intercom, speaking to the evaluation team positioned in a half-track trailing behind. Significantly more so than the Panther, The clutch brake system appears to be refined, less physical effort required. He accelerated across open ground. The Continental R975 engine, a 9-cylinder radial aircraft engine adapted for armored use, propelled the 46 tons with what felt like casual ease. Ritter had grown accustomed to the Panther's speed, its capacity to reach 46 km/h on roads. The Pershing matched this, but there was a qualitative difference. Where the Panther felt like it was straining at the leash, wrestling with its own power, the Pershing felt composed, almost leisurely in its performance. This sensation nagged at him. German engineering philosophy had always emphasized maximum performance, the highest velocity, the thickest armor, the most powerful gun that could be mounted. Compromises were made reluctantly, extracted by the brutal mathematics of metallurgy and mechanics. But Pershing suggested a different calculus. It didn't feel like a machine pushed to its absolute limits. It felt like a machine designed with margins, with reserves, with the confidence that came from industrial abundance rather than desperate optimization. After 40 minutes of driving trials, Ritter brought the Pershing to a halt near the gunnery range that had been established at the far end of the field. Here, captured or abandoned German vehicles had been positioned at various distances: a burned-out Panzer IV at 800 m, a damaged Panther at 1,000 meters, and most significantly, a knocked-out Tiger I at 1,200 m. These would serve as targets, and more importantly, as reference points for understanding what the 90mm gun could achieve. Ritter dismounted from the driver's position and climbed into the turret. Lieutenant Hans Becke, a gunnery officer from the Panzer division, was already seated at the gunner's station, his hands exploring the controls with the careful attention of a surgeon, examining unfamiliar instruments. The turret interior was spacious compared to German designs, noticeably so. The vertical space between floor and roof, allowed for easier movement, and the arrangement of equipment seemed to prioritize crew comfort in a way that German engineering typically subordinated to other concerns. "The gun mounting is stabilized," Becke said, his voice carrying a note of surprise, both horizontal and vertical. "I've read intelligence reports, but experiencing it directly is." Ritter positioned himself at the commander station. Through the periscope, he observed the distant hulk off the Tiger, its 88mm gun now silent, its reputation still formidable even in defeat. The Tiger had been the answer to the T-34, the hammer that broke through Allied armor in North Africa and Russia. It remained, even in the spring of 1945, a psychologically dominant weapon. German crews who commanded Tigers felt invincible. Allied crews who faced them felt vulnerable. And now Ritter sat in an American tank, preparing to engage a Tiger at a range where, in reverse circumstances, the Tiger would have held every advantage. "Range to target," Schultz's voice crackled through the radio. "Points 200 Meter," Becke replied. I pressed to the gun sight. "Load armor piercing. When ready, engage." The loader, a young fighter named Otto Kessler, pulled from a training battalion, had already loaded a 90mm M82 armor-piercing projectile. The round weighed 24 lb, significantly heavier than the shells Ritter was accustomed to. The cartridge case was enormous, packed with enough propellant to achieve muzzle velocities that, according to the preliminary intelligence assessments, approached 800 ms. "Ready?" Becke announced. "Fire," the gun spoke. The recoil was sharp but controlled, the entire turret shuddering momentarily before the stabilization system reasserted itself. Through his periscope, Ritter watched the tracer element in the projectile arc, across the distance, a brief orange streak against the gray sky. Then impact. These shells struck the Tiger's frontal armor with a brilliant flash, and even at this distance, Ritter could see the result. Penetration. Clean, complete penetration of the Tiger's front plate. There was silence in the turret. Not the silence of shock, but the silence of professionals absorbing a significant data point. Becke adjusted the gun slightly, traversing to bring the Panther into his sights, engaging secondary target 1,000 in Oran. Fire when ready. The second shot followed. This time Ritter watched more analytically, timing the sequence from trigger pull toe impact, approximately 1.5 seconds of flight time. The shells struck the Panther's glacis plate at the junction between the upper and lower sections, a weak point in the Palmatize armor scheme that German crews knew well. The penetration was immediate and catastrophic. Had the Panther been crewed, everyone inside would have been dead or grievously wounded. "The gun is exceptional," Becke said quietly. "The optics are clear. The stabilization allows for engagement on the move. though I'd want more practice before attempting that in combat. By the penetration hairman, I've fired 8.8 semi-torter guns for 2 years. This 90mm is achieving comparable results with what feels like less effort. Schultz's voice returned. Cease fire! All crew exit the vehicle. We'll conduct the armor examination now. They dismounted, and the technical team swarmed over the Pershing like surgeons preparing for a complex operation. Officers with tape measures recorded dimensions. Engineers with calipers examined the gun breech. Metallurgists chipped samples from the armor plate for later analysis, and in the midst of this technical autopsy, Ritter found himself standing beside Schultzer, both men studying the tank with the critical eye of professionals who understood they were observing something significant. Your assessment? Schultzer asked. Ritter chose his words carefully. It's not superior in every category. The armor protection appears adequate but not exceptional. Our intelligence suggests approximately 110 mm on the glacis, well sloped but not as thick as the Panther's frontal array. The side armor is vulnerable, probably less than 80 mm. A Panzer Faust would penetrate easily, but it's balanced. The gun is formidable, clearly capable of defeating our heavy armor at combat ranges. The mobility is excellent, probably superior to the Panther in practical terms due to the smoother power delivery and more reliable transmission. And there's something else, something harder to quantify. Explain. Ritter gestured toward the Pershing. It feels like a mature design, not a prototype rushed into production, not a compromise born from desperation. It feels like a weapon system developed with time, resources, and the confidence to test, refine, and perfect before deployment. We've been innovating frantically bigger guns, thicker armor, more powerful engines, but always racing against industrial limitations and battlefield emergencies. This tank feels like it was developed without those pressures. Schultze nodded slowly. The Americans fielded it too late for it to matter strategically. We've encountered perhaps 24 in combat, usually in small numbers, but you're correct in your assessment. This represents their matured response to the armored warfare problem. And perhaps more concerning, it suggests they've been holding it in reserve, deploying it only when satisfied with its performance. One of the engineers approached a notebook filled with measurements and calculations. Oberst Schultzer, the armor analysis is preliminary, but we can confirm thematology is high-quality rolled homogeneous plate. The welding is excellent, possibly superior to our current production standards given the labor and material shortages we're experiencing. The gun barrel shows evidence of advanced manufacturing. The rifling is precisely cut, and the chrome plating of the bore suggests they're prioritizing barrel life and accuracy over rapid production. And the fire control system? Schultzer asked. The stabilization is a significant advantage, combined with the optical quality of the sights and the ballistic characteristics of the 90mm. This tank can engage effectively at ranges exceeding 1,000 km while maintaining high first-round hit probability, in a direct comparison with our current systems. The Pershing's gunnery capability is competitive with the Panther, possibly superior in some scenarios. Competitive, superior. These were not words German engineers used lightly when assessing enemy equipment. Since the beginning of the war, German armor had enjoyed qualitative advantages that compensated for quantitative disadvantages. The Panzer III had been superior to the early war Soviet tanks. The Panzer IV, properly upjit, had been formidable. The Tiger had been dominant. The Panther had been in many respects the finest medium tank of the war. And now in the spring of 1945, with the Reich collapsing and the industrial base shattered, the Americans had fielded a tank that could meet German armor on equal terms. Ritter walked around the Pershing, his trained eye cataloging details. The tracks were relatively narrow compared to German designs, yet they'd performed well in the muddy conditions of the test range. The engine deck was accessible, suggesting ease of maintenance, a consideration that German designs often sacrificed for other priorities. The turret rotation mechanism was powered with manual backup, similar to German practice but with smoother operation. Everything suggested engineering competence married to manufacturing sophistication. We should test the gun more extensively. Ritter suggested fire it repeatedly to assess accuracy, degradation, barrel heating, any mechanical failures. The Americans have a reputation for mechanical reliability, but that's usually associated with simpler designs like the Sherman. This is a more complex vehicle. Schultzer considered this. We have approximately 60 rounds of captured ammunition, enough for a comprehensive gunnery trial. Headman Ritter, you'll serve as tank commander. Littenbecke will remain as gunner, will conduct firing exercises throughout the afternoon. What followed was one of the most thorough combat evaluations conducted by German forces in the final months of the war. They fired the 90 mm at various ranges against different target types under simulated combat conditions. They tested the gun's traverse speed, its elevation limits, its rate of fire. They deliberately stressed the vehicle rapid acceleration and braking, sharp turns at speed, sustained operation to test mechanical reliability, and with each test, with each data point collected, a picture emerged. The M26 Pershing was not a revolutionary weapon. It did not represent a paradigm shift in armored warfare comparable to the introduction of the tank itself or the German Blitzkrieg doctrine. What it represented was something perhaps more concerning from a strategic perspective. It demonstrated that American industry, having spent years producing the adequate but unremarkable Sherman, could design and manufacture a heavy tank that matched German capabilities. Not exceeded them necessarily, but matched them. And in a war that had become fundamentally about industrial output and resource sustainability, matching German quality, while vastly exceeding German quantity, represented an insurmountable advantage. By late afternoon, as the ammunition supply dwindled and the Pershing's engine finally showed signs of strain, Ritter climbed out of the turret for the final time. His uniform was soaked with sweat despite the cool March air. His ears rang from hours inside the fighting compartment. His eyes active from peering through optical sights, but his mind was clear, and his conclusions were unavoidable. Charts and graphs covered a folding table trajectory calculations, armor penetration formula, mechanical reliability assessments. The data was comprehensive and the implications were stark. "Gentlemen," Schulzer began, his voice carrying the weight of professional honesty, "we will compile a complete technical report for the Waffenamp and OKW. But let me summarize our findings bluntly. The M26 Pershing is a formidable combat vehicle. Its 90 mm gun is capable of defeating German heavy armor at battle ranges. Its armor protection, while not exceptional, is adequate for its intended role. Its mobility is excellent, arguably superior to our Panther in practical field conditions. And perhaps most significantly, its engineering suggests a design philosophy that prioritizes reliability, maintainability, and crew effectiveness." He paused, allowing the words to settle. In direct combat, a well-crewed Panther or Tiger still holds advantages. Thicker frontal armor, equivalent or superior gunnery, better trained crews, but these are marginal advantages. A decade ago, we held overwhelming superiority in armored warfare. 5 years ago, we maintained significant qualitative edges. Today, we are facing enemy armor that can meet us as equals. One of the engineers spoke up. "Could we incorporate any of these design elements into our production?" Schultz's laugh was bitter. "Incorporating what? The stabilization system requires precision manufacturing and electronic components we can barely produce. The transmission requires specialized materials we no longer have reliable access to. The metallurgy requires quality control in steel production that our current factories under constant bombardment cannot maintain. And even if we could reverse engineer every advantage, we lack the industrial capacity to produce these vehicles in meaningful numbers." Ritter understood the subtext. They weren't evaluating the Pershing to copy it. They were evaluating it to understand the gap that had emerged between German capabilities and Allied capabilities. The technical assessment was really an epitaph for German armored warfare supremacy. As the meeting concluded and the officers began to disperse, Ritter remained behind, standing in the gathering darkness and looking at the Pershing. In the dim light, it seemed almost predatory, hunkered low on its suspension, the long gun barrel extending forward like a scorpion sting. He had driven it, fired it, pushed it through its paces, and he had come away with a respect that bordered on professional jealousy. The war was lost. Everyone knew it, though few said it aloud. The question now was not whether Germany would be defeated, but how quickly and at what cost. And as Ritter stood there contemplating the American heavy tank that had briefly fallen into German hands, he understood that vehicles like the Pershing represented not just tactical capabilities, but strategic realities. America had taken years to develop a response to German heavy armor. But when that response came, it was competent, well-engineered, and backed by an industrial base that could produce them by the thousands. The next morning, as Allied aircraft resumed their systematic devastation of German infrastructure, orders came to destroy the captured Pershing. It was too valuable to risk recapture. too symbolic to allow Allied propaganda to show it being used against its creators, and too much of a burden for a military that no longer had the fuel to transport heavy equipment strategically. A demolition team rigged the vehicle with explosives, and Ritter watched from a distance as the tank he had commanded for one day erupted in flame and smoke. But the data remained. The measurements, the calculations, the test results, all carefully documented and filed in reports that would survive the war's end, would be captured by Allied intelligence teams, would eventually contribute to the historical record. And in those reports, German officers would acknowledge what many had already concluded through battlefield experience: that the qualitative advantages they had enjoyed for years were eroding, that their enemies had learned from early defeats, and that the 90mm gun mounted in the M26 Pershing represented a level of capability Germany could no longer claim as exclusively its own. The destruction of the captured Pershing did not erase the lessons it had taught. Within days, Hauptmann Ritter found himself back at the front, commanding his Panther in the shrinking defensive perimeter around the Ruhr pocket. But something had changed in how he approached each engagement. The confidence that had sustained German Panzer crews, the belief that their armor, their gunnery, their tactical doctrine were inherently superior, had been replaced by a more sober calculation. The enemy now fielded tanks that could kill Panthers and Tigers at ranges where those heavy vehicles had once operated with impunity. The 90mm gun haunted his tactical thinking. In previous engagements against Shermans, Ritter had relied on standoff distance as a defensive advantage. The Sherman's 75mm gun, even with improved ammunition, struggled to penetrate Panther armor beyond 800 mm. This created a mathematical safety zone where German tanks could engage with minimal risk. But the Pershing's 90 eliminated that margin. Any engagement that brought a Pershing within $1,000 became a fair fight. And in a fair fight, factors beyond gun performance mattered. Crew training, tactical position, mechanical reliability, and increasingly simple luck. The technical report from the Eldorf evaluation reached Wehrmacht headquarters within a week. Oberst Schulzer had been thorough in his documentation, and his conclusions were unambiguous. The report detailed not just the Pershing's specifications, but their implications. The stabilization system allowed for accurate fire on the move, a capability German tanks theoretically possessed, but rarely utilized effectively due to mechanical limitations and crew training deficiencies. The 90mm M3 gun demonstrated flat trajectory characteristics that simplified range estimation. At $1,000 meters, the round dropped only 3 mm compared to nearly 5 meters for the Panther's 75mm gun. This meant that errors in range estimation were less catastrophic, first round hit probability was higher, and engagement sequences could be compressed. But perhaps most concerning was the ammunition performance. The M82 armor-piercing round, while conventional in design, benefited from American metallurgical expertise. The penetrator was made from high-quality steel alloys that maintained structural integrity upon impact, minimizing shattering and maximizing penetration. German intelligence had recovered several fired projectiles from battlefield sites, and metallurgical analysis revealed manufacturing quality that German industry by the spring of 1945 could no longer consistently match. The steel shortages, the loss of alloying elements like manganese and molybdenum, the degradation of quality control under Allied bombing, all these factors meant that even when German guns theoretically matched Allied capabilities, the ammunition often underperformed. The report circulated among senior officers with access to technical intelligence. Some dismissed it as defaced. Others recognized it as simply accurate, and a few understood that it represented something more profound. Evidence that the technological gap Germany had exploited early in the war had not just closed, but potentially reversed. The Allies were now fielding weapon systems that matched or exceeded German capabilities, while being supported by an industrial and logistical infrastructure that Germany could no longer hope to match. Lieutenant Hans Becke, the gunnery officer who had fired the Pershing's 90mm gun during the Eldorf tests, returned to his unit with a similar sense of recalibrated expectations. He had spent years training on German optics, German fire control systems, German doctrine. The experience of working with American equipment, even briefly, had revealed assumptions he hadn't known he was making. German engineering emphasized precision and performance maximization. Every component was designed to extract the maximum possible capability from available materials and manufacturing techniques. This produced excellent equipment when it worked, but it also created systems that were sensitive to degradation, difficult to maintain under field conditions, and increasingly unreliable as manufacturing quality declined. American engineering, as evidenced by the Pershing, took a different approach. Components were designed with tolerances that allowed for manufacturing variations. Systems incorporated redundancy. The fire control system had both powered and manual backup modes. The gun included multiple sighting options. The engine, while not as powerful relative to weight as German designs, was proven in aircraft applications and benefited from decades of refinement. This design philosophy sacrificed some theoretical maximum performance in exchange for practical reliability, a trade-off that made increasing sense as the war dragged on, and maintenance became as critical as initial capabilities. Becker shared these observations with his fellow officers during rare moments of respite between combat operations. The conversations were always careful, always bound by the knowledge that criticizing German equipment could be interpreted as defeatism or worse. But among professionals who understood the technical realities, there was room for honest assessment. And that assessment increasingly acknowledged that German armor, while still formidable, no longer enjoyed the decisive qualitative advantages that had characterized the early war years. The 90mm gun's performance had particular resonance among gunners. For years, the 88mm had been the gold standard, the weapon that could defeat any Allied armor at any practical range. The Tiger's 88mm Kuk 36 and the later Kuk 43 mounted on the Tiger II represented the pinnacle of German anti-armor capability. But the American 90mm, while not quite matching the Kuk 43's performance, came close enough that the difference mattered less than other factors like mechanical reliability, ammunition availability, and crew training. The ballistic data told the story clearly. The 90mm M3 gun-firing M82 armor-piercing ammunition could penetrate approximately 170mm of rolled homogeneous armor at 500 meters at 0 obliquity. This was sufficient to defeat the Panther's frontal armor under most engagement conditions and could threaten even the Tiger's thick glacis plate at closer ranges. More importantly, the American gun achieved this. Performance with ammunition that was being produced by the tens of thousands of rounds shipped across the Atlantic in reliable supply lines and distributed to units with logistical efficiency that Germany could no longer match. By contrast, German ammunition production was collapsing. The specialized tungsten core rounds that gave German guns their best anti-armor performance were increasingly rare as tungsten supplies from Portugal and Spain were cut off. Standard armor-piercing rounds suffered from declining steel quality, and even when adequate ammunition was available, getting it to frontline units through a transportation network under constant air attack was becoming impossible. The technical superiority of German weapons was being negated by systemic failures in industrial production and logistics. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The broader implications of the Pershing evaluation extended beyond immediate tactical considerations for German armored warfare doctrine, built on the foundation of technological superiority. The appearance of equivalent Allied armor forced a fundamental reassessment. The blitzkrieg tactics that had shattered Poland, France, and the early Soviet defenses relied on armored formations, exploiting superior mobility and firepower to achieve breakthrough and exploitation. But by 1945, those tactics were no longer viable. German armored units were dispersed in defensive roles, lacking the fuel for mobile operations, facing overwhelming numerical superiority, and no longer confident in their qualitative edge. The psychological impact on German tank crews was difficult to quantify, but undeniably significant. Morale in the Wehrmacht had always been sustained partially by belief in superior equipment. Soldiers could rationalize retreats and defeats if they believed that man for man and tank for tank, they were still superior. But encounters with Pershings undermined this narrative. Veterans who had fought in North Africa remembered when a single Tiger could dominate an engagement. Now in the Rhineland and the Ruhr, that same Tiger was vulnerable to American heavy tanks that could penetrate its armor from the front. The intelligence reports that filtered down to frontline units carried warnings about the M26 point recognition silhouettes were distributed, showing the Pershing's distinctive profile, lower and more compact than a Sherman with a longer gun, and different turret shape. Tactical guidance emphasized engaging Pershings from concealed positions at maximum range, avoiding the kind of direct confrontations where the 90mm gun's flat trajectory and penetration capacity gave it advantages. But this defensive posture represented a complete inversion of German armored doctrine, which had always emphasized aggressive action and offensive engagement. Hauptmann Ritter experienced this doctrinal shift personally during an engagement near Winterberg in early April of 1945. His Panther, positioned in a concealed hull-owned position overlooking a main road, had the tactical advantage of surprise and prepared firing positions. When American armor appeared, a mixed column of Shermans and critically 2 Pershings, his immediate instinct was to wait for the optimal engagement range. Years of experience had taught him to let enemy armor advance into the killing zone, where German gun superiority was decisive. But the Pershings changed the calculation. Their 90mm guns meant that the safe standoff range had contracted. Ritter made the decision to engage at 1,200 mm, targeting the lead Pershing before it could close the distance. His gunner, a veteran named Sergeant Emil Kalk, laid the crosshairs on the Pershing's turret and fired. The round struck true, but instead of the catastrophic penetration that would have resulted against a Sherman, the shell ricocheted off the Pershing's frontal armor. The American tank's stabilization system allowed it to return fire while still moving, and although that first shot missed, it came close enough that Ritter ordered immediate displacement. The engagement lasted less than 10 minutes. The Panther managed to disable 1 Sherman with a side shot, but the Pershings proved difficult targets. Their lower profile made hull-down positions more effective. Their gun performance meant they could engage confidently at ranges where the Panther's armor, while thick, was not invulnerable, and their crews, while perhaps less experienced than German veterans, were competent enough to use their equipment effectively. The Panther withdrew after expending its ready ammunition, having achieved tactical objectives, but without the decisive superiority that characterized earlier engagements. Later that evening, as Ritter supervised maintenance on his tank, he reflected on how much had changed. In 1943, a single Panther positioned as he had been could have destroyed an entire American armored platoon with minimal risk. Now, 2 years later, the appearance of Pershings in the enemy formation forced caution, compelled tactical withdrawals, and eliminated the comfortable margins of superiority that German crews had relied upon. The war was ending not with a dramatic collapse, but with this kind of grinding erosion, each engagement a little harder, each advantage a little smaller, each day bringing closer to the inevitable conclusion. The technical specifications of the 90mm gun became a subject of almost obsessive interest among German armor officers. Intelligence reports provided increasingly detailed information as more Pershings were encountered and occasionally captured for brief examination before being destroyed or recaptured. The gun's chamber pressure was estimated at around 3,800 kilos per square centimeter, producing muzzle velocities that gave the M82 projectile excellent penetration characteristics. The barrel length of 50 calibers, meaning the barrel was 50 times the diameter of the bore, provided optimal balance between velocity and accuracy. But beyond the raw numbers, what impressed German evaluators was the systematic nature of American development. The 90mm gun wasn't a desperate improvisation or a rushed response to battlefield deficiencies. It represented a methodical progression in American tank gun development. From the 37mm gun that armed early war tanks to the 75mm that equipped the Sherman to the 76mm that provided improved anti-armor capability, and finally to the 90mm that matched German heavy guns. Each step reflected lessons learned. Engineering refined and industrial capacity applied. The Americans had the luxury of time and resources to develop weapons properly, to test them thoroughly, to manufacture them in quantity. Germany, by contrast, was improvising frantically, developing wonder weapons that often failed to reach production, and struggling to manufacture proven designs with declining industrial capacity. The Eldorf evaluation had included detailed examination of the gun's breech mechanism. The vertical sliding breech block design was different from German horizontal sliding mechanisms, but it achieved comparable rates of fire with arguably simpler maintenance requirements. The elevation mechanism allowed depression to -10 degrees significantly, better than most German tanks and critical for hull-owned fighting. The gun mount incorporated the gyroscopic stabilization system that German engineers had attempted to develop, but never successfully implemented in production vehicles. Every aspect of the gun system suggested major engineering backed by extensive testing and refinement. One detail that particularly struck the German evaluators was the quality of the gun's chrome plating. The bore was lined with a layer of hard chromium that extended barrel life and maintained accuracy through thousands of rounds. German guns, especially late war production, often lacked this refinement due to chromium shortages. The result was that German gun barrels wore out faster, accuracy degraded more quickly, and replacement barrels became increasingly difficult to obtain. The Pershing's gun, by contrast, was designed for sustained use with minimal performance degradation. Another example of American industrial sophistication. The armor protection of the Pershing had been less impressive to German evaluators. But even here there were lessons. The frontal armor, approximately 110 millimeters at 46 degrees of slope, was adequate rather than exceptional. It could be penetrated by German 88 mm and 75 mm guns at combat ranges, meaning that Panthers and Tigers retained the ability to defeat Pershings frontally. But the armor was well designed with good sloping that increased effective thickness and encouraged deflection. The turret armor was particularly robust with 115 mm on the gun mantlet that made frontal turret penetrations difficult, even for German heavy guns. More significantly, the armor quality was consistently high. German metallurgists who examined samples from captured Pershings noted the uniform grain structure, the lack of inclusions or flaws, and the reliable hardness values. Late war German armor, by contrast, suffered from increasingly variable quality as steel production faced shortages of alloying elements and quality control. Degraded under bombing armor plates that should have provided equivalent protection sometimes failed, catastrophically due to metallurgical defects. The Pershing's armor might not have been the thickest, but it was reliably effective. Another example of American industrial advantages translating into battlefield capabilities. The mobility characteristics of the Pershing had impressed Ritter most during his driving evaluation. The Continental R975 engine, producing 500 horsepower, gave the 46-ton tank a power-to-weight ratio of approximately 10.9 horsepower per ton. This was actually inferior to the Panther's ratio of 15.5 horsepower per ton, suggesting that on paper the Panther should have been more mobile. But the paper specifications didn't capture the practical reality. The Pershing's torque-o-matic transmission translated engine power to the tracks more efficiently. The suspension provided better traction. The wider tracks distributed weight more evenly, and perhaps most importantly, the entire drivetrain was more reliable, meaning the tank's theoretical mobility translated more consistently into actual battlefield performance. German tanks, particularly the Panther and Tiger, were notorious for mechanical unreliability. The Panther's final drive was prone to failure. The Tiger's transmission required careful handling to avoid breakdowns. The cooling systems on both tanks were barely adequate for sustained operation. These mechanical vulnerabilities weren't design flaws. In the conventional sense, German engineers were aware of the issues but lacked the time, materials, and manufacturing capacity to fully resolve them. The result was that German tanks often performed brilliantly when they worked, but spent considerable time in maintenance, and breakdowns during combat operations were common. The Pershing, by contrast, benefited from American automotive engineering expertise. The R975 engine had been used in aircraft and was thoroughly proven. The transmission, while complex, was manufactured to tolerances that ensured reliability. The cooling system was adequate for sustained operation. The tracks, road wheels, and suspension components were designed for replacement and repair under field conditions. The entire vehicle reflected a design philosophy that prioritized reliability and maintainability, accepting some compromises in maximum performance to ensure consistent practical capability. This engineering philosophy extended to crew ergonomics in ways that German designs often neglected. The Pershing's turret interior provided adequate space for the crew to operate efficiently. The commander's position included excellent vision devices and communication equipment. The gunner's station incorporated high-quality optics and intuitive controls. The loader had sufficient room to handle ammunition without excessive fatigue. Even the driver's compartment, while cramped by absolute standards, was better designed than comparable German positions. These ergonomic considerations might seem minor compared to gun performance or armor thickness, but over the course of sustained combat operations, Crew fatigue and efficiency significantly impacted tactical effectiveness. The ammunition stowage in the Pershing demonstrated another design refinement. The rounds were stored in protected bins below the turret ring, surrounded by liquid-fill sponsons that provided both blast protection and fire suppression. German tanks typically stored ammunition throughout the fighting compartment, increasing the risk of catastrophic detonation when penetrated. The American approach to ammunition stowage reduced this vulnerability, improving crew survivability in combat. Again, this represented mature design thinking, not just maximizing offensive capability, but also considering defensive resilience and crew protection. As April advanced and the collapse of organized German resistance became inevitable, the lessons from the Pershing evaluation took on an elegant quality. The technical reports documenting American armor capabilities would survive the war, would be studied by military historians, and would inform post-war tank development. But for the men who had conducted those evaluations, who had driven and fired the captured Pershing, the knowledge was bittersweet. They had gained insight into enemy capabilities at a point when that insight could no longer alter strategic outcomes. The war was lost, and the superior American industrial base that produced tanks like the Pershing would soon occupy Germany. Headman Ritter survived the war's final weeks, surrendering with his unit to American forces in late April. His Panther, which had carried him through the final desperate defensive battles, was abandoned intact when fuel supplies finally vanished. In the years that followed, he occasionally encountered American veterans, and conversation sometimes turned to the armor they had faced. When Ritter mentioned having driven a captured Pershing, the Americans expressed surprise. Few German soldiers had that experience, and when he described his assessment of the 90mm gun, they nodded in recognition. They had known they were fielding a capable weapon, but hearing confirmation from an experienced German Panzer officer carried particular weight. The M26 Pershing itself had a brief combat career in World War II, arriving too late to significantly impact the European theater's outcome. Only a few dozen saw combat in Germany during the war's final months, but it served extensively in the Korean War, where its 90mm gun proved effective against Soviet-supplied T-3485 tanks. The design lessons incorporated into the Pershing informed subsequent American tank development, leading to the M46, M47, and eventually the M48 pattern series. The 90mm gun remained in service for years, a testament to its effectiveness and the soundness of its design. For German armored warfare, the Pershing represented a closing chapter. The technological superiority that had characterized German armor in the early war years had been eroded by Allied development and German industrial collapse. The Panther and Tiger remained formidable weapons when they could be kept operational, but they were products of a failing industrial base facing overwhelming material disadvantages. The appearance of tanks like the Pershing, capable of meeting German heavy armor on roughly equal terms while being produced in numbers Germany couldn't match, symbolized the broader strategic situation. Germany had pioneered modern armored warfare, had developed some of the war's finest tanks, but had ultimately been overwhelmed by enemies who combined adequate technology with superior industrial capacity. The technical report from the Eldorf evaluation filed in March 1945 concluded with an assessment that was remarkable for its honesty. Oberst Schulzer wrote, "The M26 Pershing represents a competent heavy tank incorporating advanced fire control systems, adequate armor protection, and reliable mobility. Its 90mm gun is capable of defeating German heavy armor at battle ranges. In direct comparison with our Panther and Tiger tanks, the Pershing offers no decisive advantages in any single category, but achieves a balance of capabilities that makes it a formidable opponent. More significantly, it demonstrates that American industry has overcome early war deficiencies in tank design and can now produce armor that matches German quality while vastly exceeding German quantity. Recommendations for countermeasures are limited by current industrial and strategic constraints." That final sentence captured the essential tragedy of late-war German armored warfare. The technical knowledge existed. The tactical expertise remained. Individual German tanks and crews could still achieve impressive results. But the systemic advantages that had enabled German success, industrial capacity, resource access, technological edge, had eroded beyond recovery. The Pershing and its 90mm gun were simply the latest evidence of a transformation that had been underway since Stalingrad, since the Battle of Kursk, since the Normandy landings. The Allies had learned from defeat, had adapted their equipment and tactics, and had brought overwhelming material superiority to bear. For the men who had evaluated the captured Pershing, the experience remained memorable decades later. They had glimpsed in mechanical and ballistic terms the capabilities of an enemy who no longer needed technological inferiority to be excused or explained. The war had begun with German armor breaking through lines of inferior Allied tanks. It ended with German armor defending desperately against Allied tanks that could meet them as equals. And in that transformation lay the story of the war itself, not just of battles won and lost, but of industrial capacity mobilized, of technological development accelerated, and of initial advantages systematically negated by enemies who refused to accept permanent inferiority. The 90mm gun that had so impressed German evaluators continued to serve in various applications long after World War II ended. It armed not just the Pershing but subsequent American tanks, was adapted for anti-aircraft use-equipped tank destroyers, and influenced the development of later high-velocity tank guns. The design principles embodied flat trajectory, high muzzle velocity, reliable penetration became standard for Cold War armor development. In that sense, the gun represented more than just a single weapon system. It represented a maturation of American armor design philosophy, a closing of the technological gap that existed in the early war years, and a foundation for the armored warfare capabilities that would define the second half of the 20th century. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now.